Today, we're going to be speaking about 3D printable concrete. Well, moreover, we're going to be watching an animation about 3D printable concrete. We're going to take a look at how it works, we're going to look at how it's deployed, and what makes it so special. Because I had to learn about it too, so now I've put this together so you can learn it as well. 3D print a concrete wall, you need a very special kind of concrete. We start with fine sand, cement, a little bit of water, and some short fibers. These fibers act like tiny invisible threads that help the concrete stay mechanically strong and cohesive. Our first helper is the super plasticizer. Scientists make it by linking polyethylene glycol and acrylic acid to create long comb-shaped molecules called polycarboxylate ethers. These combs wrap around cement grains. Their side chains spread out like arms, pushing other grains away so the mixture flows smoothly even though we use very little water. Next, we add a viscosity modifying agent called hydroxypropyl methylcellulose. It comes from plant cellulose, wood or cotton fibers. It forms a gentle gel that holds water in place, and this keeps the printed ropes from bleeding or collapsing on each other. We start with dry ingredients, sand, cement, and sprinkle in fibers. Then our flow helper, the super plasticizer, coats the cement. We add water and stir, and finally we sprinkle in the thickener. This sequence makes a smooth, thick dough that can be pumped through the printer. Once our mix is ready, it doesn't just magically appear in the printer. It has to be pumped, and sometimes tens of meters through hoses, bends, and fittings. That means the mix must be strong enough to hold together, but soft enough to flow under pressure. This is where the pump and the mix work as a team. Regular concrete uses big rocks. Those rocks are great for strength, but terrible for pumping through small hoses. 3D printed concrete uses fine sand only, so nothing gets stuck. The super plasticizer lets the mix slide, and the viscosity modifier keeps everything together so it doesn't separate under pressure. Sometimes we need our concrete to harden faster, especially when printing in cool weather. We add accelerators such as calcium nitrate or triethanolamine. These chemicals introduce extra calcium ions or change the hydration chemistry, speeding up how quickly the cement and water form crystals. Because the mix is already low in water, the accelerator helps the walls gain strength within hours. On extremely hot days, our mix can set too quickly. To prevent this, we add a small amount of a retarder. Natural compounds like sucrose, citric acid, or tartaric acid attach to the cement particles, slowing the reaction just enough to avoid cracking. Another retarder, sodium gluconate, is derived from glucose. We use these sparingly. There are mainly two different types of printers, a 1K printer and a 2K printer. A 1K printer uses one complete concrete mix. Everything cement, sand, fibers, chemicals is mixed together before pumping. The mix must be perfectly balanced, pumpable, printable, and able to harden at the right speed. Whereas a 2K printer uses two materials. The main concrete mix is pumped first. A second line delivers a chemical activator, usually an accelerator. These two materials only meet right at the nozzle. Why this matters? Well, this gives engineers much more control. The concrete stays workable in the hose and then hardens instantly when printed. Whereas a 2K printer uses two materials. The main concrete mix is pumped first. A second line delivers a chemical activator, usually an accelerator. These two materials only meet right at the nozzle. Finally, the printer squeezes out long ropes of our mix. The super plasticizer keeps the ropes flowing, the viscosity modifier stops water from bleeding, the fibers add strength, and the accelerator or retarder makes the reaction go at the perfect speed. Regardless of whether it's a 1K or 2K system, the goal remains the same: a concrete wall that prints cleanly, cures quickly, and performs like a traditional structure. Well, that's everything I learned about 3D printable concrete. If you found this useful or you like this type of information as we kind of mixed it up today, then leave a comment and let us know. Also, don't forget to hit the like button and the subscribe button, and we'll catch you on the next one.